Hello and welcome to screencast number 6 on Chapter 20, Conventional Energy Alternatives. We're going to conclude our look at nuclear energy with this slide, and then we're going to turn our attention to bioenergy and what we can gain from bioenergy sources, and look at biopower in generating electricity from biomass, and we'll start to focus on that. So in conclusion, we can see that there's multiple dilemmas that have slowed nuclear power's growth. There have been major concerns over waste disposal. Where are we going to put this uranium-238 and the rods and the waste that's produced from this? The safety and the cost have also affected the nuclear power's growth as well. Of course, things like Chernobyl and Fukushima, they have created public anxiety where it's really put a black cloud over, I wasn't trying to be funny there, but I guess it was, a black cloud over the idea of nuclear power because of the risks that are involved. And this has made utilities less willing to build new plants because of the risk associated with it. It's enormously expensive to build and maintain and operate these plants, especially when you're trying to ensure the safety of the nuclear facilities. Almost every plant has overrun its budget. The plants are aging faster than they predicted because of their exposure to radiation, and several serve less than half their expected lifetimes. So they've been decommissioning and shutting down plants because of the more expensive ways of repairing it than it is to construct new ones. So we have seen that the electricity from the nuclear power plant costs more than from coal and other sources because of that. And the governments must subsidize the nuclear power to help make up the difference. The U.S. nuclear industry has stopped building plants, and of the 256 U.S. nuclear reactors that were ordered since 1957, most or about half of them have been canceled so that they will not be built. It would be great if we could expand the nuclear capacity and decrease our reliance on fossil fuels, because we know that it will cut greenhouse gas emissions. So those people that are in favor of cutting the greenhouse gas emissions, they are very supportive of nuclear power, and a lot of environmental advocates are also trying to support it. Engineers are planning different ways to make nuclear power plants safer and less expensive. So there still is a team out there working to try to make a better system. So now let's take a look at bioenergy. And bioenergy is also known as biomass energy. And this is the energy that is obtained from biomass sources. You may recall from your general biology days that we talked about a biomass pyramid, which is the total amount of living material, and the sources of those living materials are represented within that pyramid. This consists of organic material derived from living or recently living organisms, and this material contains chemical energy that originated with the sun through the process of photosynthesis. So we're talking about plant matter, and this could include wood from trees. It could include charcoal from wood that has been charred in the absence of oxygen. It could be matter from agricultural crops. It could also be combustible animal waste products such as cattle manure. They're actually making what they call cattle chips that you can put into your fires and fireplaces and burn. There's a great attraction of bioenergy uh, because it's renewable and it releases no net carbon dioxide into the atmosphere. The of biomass emits plenty of carbon, but they figure in calculating it that it's balanced by the fact that photosynthesis had pulled in this amount of carbon from the atmosphere to create the biomass just years or months or weeks before. Therefore, in theory, we're replacing fossil fuels with the bioenergy. We reduce net carbon flux to the atmosphere, and we help to alleviate the global climate change. But in practice, it's not that simple. Judging the sustainability of any given bioenergy strategy requires careful consideration. We have to consider what type of biomass source we are using and how we gain energy from it in order to determine its effectiveness. So I think I'm just looking at this screen, so we didn't cover this. So when we consider bioenergy and its many sources, we can take a look at the poor farmer in Africa, where bioenergy entails cutting wood from trees, collecting livestock manure by hand, and then burning it to heat and cook for their family. To the industrialized farmer, though, maybe somebody from Iowa, bioenergy means shipping his grain to a high-tech refinery that can convert it into a liquid fuel that could be able to be used to run our automobiles. So we see that there's a diversity of sources and approaches that involve bioenergy, and this gives us many ways to address our energy challenges. About 1 billion people use wood from trees as their principal energy source. Developing nations, especially in rural areas, and families gather fuel wood to burn in their homes for heating and cooking and lighting. Fossil fuels are being replaced by traditional energy sources, and developing nations that are industrialized move away from the fuel wood and the charcoal, but it still accounts for about 90% of the energy in the poorest countries. Fuel wood and other traditional biomass sources constitute 3/4 of all renewable energy used in the world. Biomass is renewable if you manage it wisely, and you do have to use it sustainably. So you have to replace what you're using so that it doesn't lead to deforestation or soil erosion or desertification that we talked about earlier in the year. We don't want it to damage the landscapes, and we don't want it to diminish biodiversity or even impoverish human societies. So taking a look at this data table, it shows you that wood, charcoal, and manure is used for direct combustion for heating, where biofuels that could power vehicles come from corn, sugarcane residue, soybeans, and rapeseed. And we're using cooking oil for biodiesel. So this is stuff that, we're in our fast food restaurants. They're even talking about using that. When we look at biopower for generating electricity, we're using crop residues, forestry residues. We're processing wastes that we get from sawmills, pulp mills, and paper mills. We're actually trying to harness the gas from landfills, and we're using livestock waste that we collect from feedlots and organic components of municipal solid wastes that are from the landfills. And I think we saw that last one happening at the wastewater treatment facility. So anyhow, as we continue to look at this, populated arid regions that support meager woodlands are most vulnerable to over-harvesting, so we need to watch out for that. And those consist of regions of Africa and Asia. they burn fuel wood and other biomass for cooking and heating, and in the way that they burn it, it leads to health hazards from indoor air pollution because a lot of them don't have fireplaces or wood-burning stoves that you would think of that would harness that energy and move the smoke out. So they actually live in carcinogenic huts because the smoke actually fills the room. Although much of the world still relies on fuel wood and charcoal and manure, new bioenergy approaches are being developed, and they're using a variety of materials to provide innovative types of energy. The biomass sources that can be burned in the power plants we call biopower, and this generates heat and electricity. And then the other sources that we have can be converted into liquids, which we call biofuels. And this is what we're hoping to use to power automobiles. Many of these novel biofuels and biopower strategies really depend on technologies that have resulted from extensive research and development. They're being developed primarily in wealthier industrialized nations, just like the United States and in countries like Sweden. So here's a person, a woman who is carrying the wood she needs in order to be able to have a fire and cook her meals. So let's look a little bit more about biopower and how biopower can generate electricity from its biomass. So we can combust biomass to generate electricity, and we can do this in the same way that we use coal for power. There are waste products that can be used as sources of biopower. The forest industry really generates a large amount of woody debris that we can use from their sawmills, from their pulp mills, from their paper mills. Sweden is a really good example of this, where it's a largely forested area, and they are using the timber industry as a major part of their economy. And they're using the biopower that it produces from the logging industry there. Waste sources include residue from agricultural crops as well that could be biopower. We can use corn stalks and corn husks, and we can also use the animal waste from feedlots that we previously mentioned. And we can also get organic waste from municipal landfills. What happens in these landfills is the anaerobic bacteria will break down the wastes in the landfills, and this actually produces methane, and we call this landfill gas. So we can get our energy from there. That methane and other gases can also be produced in a more controlled way in anaerobic digestion facilities, and we saw the digester at the wastewater treatment plant, and we know that produced methane gas because they had it burning in the back. So this is biogas, and this can be burned in the power plant's boiler to generate electricity. So if we could generate electricity off of the wastes from the waste that are taken into these wastewater management systems, and that could be another knockoff as an improvement of the plant. I also want to mention bioenergy crops, and these are being grown specifically to generate power. And these are going to be anything that's fast growing grasses such as bamboo and switchgrass. They're going to be trees that are specially bred like willows and poplars. Both willows and poplar trees can grow very quickly. Poplars are known for being able to convert carbon dioxide and store carbon dioxide at not excessive rates, but large rates. I don't know so much about willows. I know poplars are like that, but they're growing these again for bioenergy because these plants can produce liquid biofuels. So here are some poplar trees